I hear from you, this is not about something that is like 5 years back, what people used to do. This is what is needed right now in the industry. And understanding these aspects allows people to kind of understand not only what's going on and also get a foot into the industry. Am I right if I say something like that?
Yeah, absolutely. I would say within automotive OEMs at the moment, the key skills that they're predominantly looking for are things like CAE modelling, simulation experience, because every single company has got some program in place where they're trying to improve their use of virtual tools and methods. So that's absolutely paramount. And then to go with that, they then got a big focus on mechatronics and control system development, because they want to be using these active suspension systems to improve the performance of their vehicle. It's one other thing I should have touched on with the project is that in this project, what I want people to also focus on is a particular niche of the use of active suspension systems. So the active suspension systems have actually been around for quite a long time, probably 15, 20 years now since the first systems were introduced. Back then, the world was quite a different place. We didn't have the same focus on sustainability that we have nowadays. Obviously, everything now wants to be zero emissions or low emissions if it's an internal combustion engine vehicle. So what manufacturers are now trying to do is they're trying to use these active suspension systems, but in a way that minimises their impact on emissions. So historically, because you were using an active suspension system, you were driving current into an actuator, which was using energy. They're now trying to find ways to minimise that energy usage, but still get the benefit of these systems and what they can offer. So that's the other part of the project I want people to be focusing on, that is very, very relevant to what's happening in the world today in terms of sustainability, is how we can use them in an energy efficient manner.
One of the questions that a lot of people asked was about what are the key skills that they develop, right? And I think you summarized it well. So in the industry right now, CAE modeling and simulation is not only vehicle dynamics, right? Like every engineering department has a simulations and a modeling kind of an atmosphere to make sure they do the best before even going to kind of build the vehicle. And then mechatronics and control systems, understanding that aspect of it, especially the niche areas of active suspension systems and how we can basically, even when there is different power sources, how do we kind of make sure we still have an active suspension system that kind of works. One of the questions that we had was the candidates who work on this, what kind of opportunities that they need to kind of, as a continuation to this. Say I'm a fresh undergrad graduating in 2020, I'm doing something like this, I have some formula experience, I'm doing something like this, and I want to kind of get into an industry. What should the next steps be, and what is the pathway that you would suggest?
Yeah, so I think this project is probably fairly equivalent to a postgraduate master's level thesis project in terms of the level of complexity. So it kind of, I guess it opens two pathways. You potentially, if you wanted to continue to focus on academic studies, it could be a quite nice lead into perhaps pursuing PhD, postdoctorate studies. But obviously, if you're focusing more on moving into the industry itself, then what it should do is it should give you a pretty good chance, I would say, of being able to approach an OEM and successfully apply for a position in a chassis engineering or vehicle dynamics department where they're looking to do either CAE simulation or active system development. As I say, pretty much all OEMs at the moment are looking to do that. You may potentially be able to get a role that's not specifically just graduate level, potentially a little bit up from that, because you've demonstrated you've got some skills and experience in that field. So you'd be sort of talking that kind of sort of junior engineer role, but not necessarily just a pure graduate engineer role.
Say, for example, you entered, post your undergrad, you entered into electrical engineering domain, but you wanted to be in vehicle dynamics. Say, for example, that's one example, or the other example is I'm in vehicle dynamics, but I'm just a new into vehicle dynamics, If people in that sphere take up these research projects, where would they go?
Yeah, so obviously using my own example, I was in electrical engineering and I did a master's degree, and that then really opened the door for me to move across into chassis engineering. So this I would expect would give people exactly the same sort of opportunity. You know, you'd be able to say to people, you know, potentially within your own business, I've done this project, I've demonstrated I've got the skills. Would it be possible for me to move across now into a related role within the business? For somebody who is already in a vehicle dynamics role, perhaps a junior level role, it's a great way to gain a much broader understanding of the field, because we're going to be touching on a lot of different things in terms of the base understanding of vehicle dynamics, the use of simulation, the use of these sort of new active suspension systems. So it should really help to accelerate your progression, I would say, because you're hopefully going to gain a big understanding of a lot of different fields that would be very, very useful to help accelerate your career. You're talking probably in 3 months gaining hopefully the sort of experience that you might only get in about 2 years within actually working, because inevitably when you're working you've got certain tasks that you have to do, and it doesn't always give you opportunities to develop. So this being so focused will hopefully accelerate that.